Welcome to part 3 on linear equations. So, if you've made it through parts 1 and 2, great job! There's a lot of information in these videos, and it's great that you're taking the time to improve your understanding. In this video, we're going to start with some information we've seen before. We have our y equals 2x minus 1. We're going to stick with that equation. And we have our graph on the right that displays our line, our y equals 2x minus 1, our linear equation. And now we're going to focus a little bit more on our 2 here, our slope. Remember we said that this number determines the direction of our line, and we say that each time we increase x by 1, y increases by 2. So in other words, the 2, our red 2 here, represents how much y changes when we increase x by 1. The 2 represents how much y changes when we increase x by 1. So we increase x by 1, y goes up by 2. So that's good. That is good. That's how we're going to define our slope. Remember, our slope in general terms is going to be this m. So let's give it a nice little definition. We'll say that our slope, m, equals how much y changes when we increase x by 1. You'll often see this written as how much y changes is how much we go up or down. So that would be how much we rise on our graph. And when we increase x, we go left to right. That's called running. You run left to right, you rise up and down. So rise divided by run, that is the formula for slope. Let's dig into that a little deeper so we understand what that means. So let's look back up on our graph and let's pick a couple points. Let's say I'll pick this point. This is going to be the point x equals 3, y equals 5. And then let's just stick with this point right here, 1, 1. And to get from 1, 1 to that point x equals 3, y equals 5, what do? Well, we run from 1 to 3. We call that running. From x equals 1 to x equals 3. And then we rise up to 5. We rise. And so if we think about our equation, our rise over run, what does that say here? Rise over run says we are rising how many units on our y? So when we're rising, we're starting from this spot and we're going up, right? So that means we're starting from this 1, y equals 1, and we're rising all the way up to 5. So we're going up 5 minus 1, 4 units, or 4 steps. You can say 4 steps. We're taking 4 steps in the y direction. Okay. And so, how much did we run? Well, we started over here. We started at x equals 1, and then we ran over to x equals 3. So we ran 2 steps. So we ran 2 steps in the x direction. 4 steps in y, that's how much we're changing for every 2 steps in x. And if we do 4 divided by 2, we get 2. And that would be our slope. But what does that mean? Let's think about this a little deeper. I feel like we might have missed something in our understanding. Yeah, we got an answer, but do we know what that means? So, how about we think about this 2 differently? 2 is the same as 2 divided by 1, right? Well, let's think about it that way. Let's get rid of that 2. And we're going to think about it as 2 divided by 1. In other words, 2 steps in y for every 1 step in x. That's what it means when we're doing 4 divided by 2. We're bringing it to a per step in x kind of measurement. So we're saying 2 steps in y for every step in x. So instead of thinking 4 steps in y for every 2 steps, doing this division just breaks it down into a per step measurement. Okay? Rewind that if that was a little too much at once. So when you have 2, 2 is the correct answer. Rise over run equals 2. But you want to understand what that means. What are we trying to communicate? We're saying every time we make 1 step in x to the right, we're going up 2 steps. And that's the same as saying when we take 2 steps in x, we're going up 4. All right. And again, this matches with our definition over here. We said how much y changes when we increase x by 1. Well, that's what this number says. We're saying y goes up by 2, it increases by 2 when we increase x by 1. So it's helpful to think of this as we said, steps. And this idea of running and rising, that is going to be really helpful to think about. And you can think of it just as regular running when you're running around a track. Someone is starting here and running across. And the same, like you're in an elevator, you are starting here and you're rising. And so that's the same idea. Rise over run, it's showing how much you change in y per change in x. And then doing that division and bringing it down to a 2 gives it into a per 1 step in x. Kind of breaks it down into simpler terms. So, now that we've gone over this idea, how about we do an example? Oh, an example. We haven't seen one of those in a while. All right. Now that we've learned our idea of a slope, how about we find the slope of the line graphed below? So this is our graph. So we want to find the slope of the line graphed below. So again, we have our x-axis, y-axis, we have our little chart, and we drew a line. And so we want to find the slope. So let's start off by writing our definition of a slope. Our slope, m, remember we use m, that variable for slope, is going to be our rise over run. Okay, we have 2 points on the graph. Going from one to the other, how much do we rise? Well, this point is at -2, right? So it's right here. And then we're going up to this other point, and that's at y equals 3. So it's up here. So starting here, we rise up to that 3. So we can say that we rise how many units? Going from -2, you can say you're taking 2 steps to get to the center, and then 3 steps up. So you're going a total of 5 steps. You're going up plus 5. And then how much do you run to get to the left green point? Well, we're running from, right here would be x equals 4, and that's what we see in our coordinate here. And then we're going all the way over to x equals -2. That's where this point is. So let's run over there. All right. And how much do we run? Well, we run starting at the 4, starting at this 4 over here. We'll run 4 to get to the center, and then 2 over. So that means we're running 6. However, we're running to the left. And when we do that, we say we're running -6. So why do we say that? Well, we say that because our x is actually decreasing. Remember, we keep our positive x values over here and our negative x values over here. So when we go from our positive x equals 4 and go to a negative, we say that we're running -6. We're running, think of it as running backwards, essentially. So now that we know our run, we know how much we're rising, let's put it into our formula here. So we rise 5, and then we run -6. However, if you notice, we only took one perspective here. We thought about running from this guy right here, this point, to the other point. Well, what if we did it the other way around? What if we started up here? Well, let's do that. We're going to start up here and try to get to our bottom point. Okay, so how do we do that? Well, that means we would go down to -2. And what's that -2? That is this right here. We started at y equals 3, that's where this top dot is, and then we go down to y equals -2. And so what happened there? We rise 5 units. We went from y equals 3 down to y equals -2. However, again, we went from a positive y to a negative, so we say we rise -5. And now we have to run across. We're here, and now we run all the way over to our second point. How much do we run? We run from -2, which is up here, -2, over to 4. And so we run +6. And here's 4. Since we went from our dot up here to our dot down here, we have a different rise and run. That means putting into our formula, we rise -5 and we run 6. However, these are still the same thing, right? 5 divided by -6 is the same as -5 divided by 6. It's just 5 divided by 6 with the negative sign in there. So usually we just write it as this with the negative sign up front. And so why did I show those two different ways? It's just that those are the two ways to look at this graph, right? We can either think about it in our first way, where we go up and then to the left, or you can think about it our second way, where we go down 5 and then to the right. So it's important to realize that you can think of a line as these two different things. So how do we interpret this -5/6? It's important to understand what are we doing? What do these numbers mean? Let's think about it starting step by step. So this right here, we said we rise 5 for every 6 units we run to the left, right? Every time, that's what this example up here was, these two circles. We go 5 up for every -6 we go to the left. This one said it the opposite way. It said we go down, that's what these two circles were. We go down 5 for every 6 that we run to the right. And this, remember, we, in our first example up here, we see that this equation, our rise over run, brings it down to a per one step in x. So it brings it down to a way of thinking that is a little easier to understand. So we can say that when we have our final answer right here, we can say that for each increase in x by 1, y changes by -5/6, or you can say it decreases by 5/6. That is another way to think about it. So there's a few different ways to think about it, right? Like we talked about this way right here and this way, thinking about going from one point to the other. And now we're thinking of a per one step in x. How can we see that on the graph? Well, pick a point, pick any point. I'll pick a point right above 1. So it's saying every time we increase x by 1, y decreases by 5/6. That's what that negative part refers to. So there's a few different ways to think about it. So take some time to review this example and convince yourself that, yeah, there are different ways to think about moving from one point to the other. And how about I ask you this? What if we just had these 2 points? What if they told us we had our x equals -2, y equals 3, and we had our point here, x equals 4, y equals -2. And what if we didn't have a graph? What if we couldn't visually rise and run? What could you do? We know that our slope equals rise over run. Another way to think about that is if we, let's say instead of this point here, x equals 4, y equals -2, let's just call that x1, y1, just making it general. And the other point is going to be x2, y2. So it's our second x and our second y. Let's think about it that way. So our slope, we can think of it as rise over run, or we can just think of it as our change in our y's. y2 minus y1. How did our y's change? How much did we rise? And then we divide it by how much we run, which is how much we move along the x-axis, which is x2 minus x1. So these 1s and 2s, it's just to say we're looking at our first point here, x1, y1, and then we have our second point here. And you can think of it like this. You can think of doing, if you didn't have a graph that you could visually rise and run, you could just look at our 2 points and see it like this. So we have what is our y2? Our y2 would be this guy right here. That is our second y. And then we subtract our first y, which is here, -2. We'll put it in parentheses to make it look a little clearer. And we'll divide by our x's. What's our second x? Our second x is over here. Ooh, it's starting to get really messy. That is -2. And then we subtract our first x. That is 4. And then we can keep going, and this equals, what is 3 minus -2? That is the same as saying 3 plus 2. So we'll have 5 on top, and then divided by -2 minus 4 is -6. So we got that same answer. So if you have a graph, you can rise and run. If you don't have a graph, you can think about the y's and the x's. Think about your first point and your second point. So really understanding what this rise and run means can help you figure out the problem. And here's a little tip. We saw that this line up here, this green line, that goes up and to the left. And we saw that it has a negative slope, right? Our very first example, our slope was positive. It was 2. And that made our line go up and to the right here. This is our line. It went up and to the right. So this direction, anytime you have a positive slope, our line is actually going to go in that direction. And anytime we have a negative slope, our line will go in this direction. So let's make that note. If the line goes up and to the left, it has a negative slope. That's always going to be true. So if a line goes up and to the left, that is always going to have a negative slope. And on the other hand, if the line goes up and to the right, it has a positive slope. Positive slope. And so if a line goes up and to the right, so something like this, it has a positive slope. So that's something I am telling you. I'm telling you anytime a line goes up and to the left like that, it has a negative slope. Anytime it goes up and to the right, it has a positive slope. So based on this example that we just did, I encourage you to think about these two items in purple and figure out, why is that true? I told you that is true, and it is true, but why? Use our example, think about points. Well, here's a little hint. Think about points that you could put onto the line, any random 2 points, and think about this idea of a rise and a run. See what happens when you rise and run from one point to the other. And you can think about any line that goes up into the left or up into the right. It doesn't matter. So think about those rises and runs and convince yourself. Convince yourself that anytime a line goes up into the left, it's going to have a negative slope. And if it goes up into the right, it has a positive slope. So take some time and think about that. We will move on to our final example here, and that is, you are given the slope of a line and a point on that line. So here they are. Slope is equal to 3/4, 3/4, and our point is going to be x equals 5, y equals -7. So your task, your question, is to find the equation of the line. What is the equation of the line? Okay. So first off, it always helps to draw a picture when you're given a problem about lines. So how about we just draw a rough picture? We have some information, right? We have a point and we have a slope. So let's just make a little quick chart. We have a point, x equals 5, y equals -7. Where would that be? Remember, positive x's go in this direction, so we're going to move down that way. And then negative y's, they go down this way. So somewhere in here is going to be that point. So let's just plot it somewhere. And we see that our slope is 3/4. That's positive. What did we just learn? Positive slopes mean that the line goes up and to the right. So we can already tell that our line goes up and to the right. So that's what our line looks like. We have a point, we have a slope, we know it goes up and to the right, and we need to find the equation. Well, what is the equation of any line? Y equals mx plus b. And it looks like we already know our m, our slope, it's given to us. And that means we need to find b. That is our goal, find b. Find this guy right here. Because if we know our m and we know our b, we have the equation of a line. So how can we do that? Let me start off by putting our m in there. We already have that variable, so we know what's underneath the mask. It's 3/4. So now what? Well, we have a point, and remember a point is a solution to the equation. It's something that we can plug back into the equation, and it'll maintain that equality. So how about we do that? We're given, it looks like an x here and a y, and we have an x and a y, we could plug it in, and if we know those two, we can figure out what b is. Okay, let's plug in y, that would be -7, right? -7 equals 3/4 times x, which is 5, plus b. We're going to see that as 15/4. And now, what do? We want to get b by itself. We want to figure out what it's equal to. So we subtract 15/4 from each side. Remember, we have to do the same thing to each side because it's an equation. That is going to leave us with, so we'll have -7. So I'll rewrite that as -28/4. Why did I do that? Because we have to subtract 15/4. So I'm trying to get that like denominator because we have to do a little subtracting with fractions. And then on the other side, this cancels out and we're left with b. This is -28 minus 15 on top, so that's -43, and then divided by 4 on bottom. That is our answer. That is what b is. If you want to rewrite this, you could rewrite it as -10 and 3/4. That's what b is. So we know what m is. We were given m. We figured out what b is, so we can write the equation of the line. So we say the equation of the line is, well, what's our general form? We have our y equals mx plus b. And so we know m is 3/4. That's what that is. Y equals 3/4 x plus b. What is b? It is -10 and 3/4. That is the equation of our line. And why was it helpful to draw a picture at the very beginning? Well, you can use it to guide you and kind of double check. So we see in our answer of our equation, we have a y-intercept of -10 and 3/4. So our chart, it should cross the y-axis in a negative area, right? And in a similar way, we have a positive slope here. We should be showing a positive slope on our picture. And we do, since it goes up and to the right, up and to the right. So using a picture can help you. It can help you double check if you, let's say, for example, your b was positive, and that would mean that your y-intercept is up here. Well, if your graph looks different, then that means something is wrong. Either there's an error with your graph or an error with your equation. So definitely drawing a picture can help you. In any math concept, if it's possible to draw a picture, go ahead and do it. It can help you work through the problem. And now that we've worked through a couple examples, over the past 3 videos, we've stepped through what a linear equation is, what is the slope, what is the y-intercept, on a really deep level, understanding what these ideas mean. And so the only way for you to really get your understanding down is to practice. You need to practice plenty of problems, enough to see some different kinds of ideas. See, each of these problems I gave is worded differently. It gives this linear equation concept kind of a different look. There's different ways to look at it. So do plenty of questions and make a list. It's helpful to make a list of which questions, which concepts you're struggling with. And take that list, to your teacher during class, after class, and get help. That's how you improve in Algebra 1. You do plenty of problems, you watch videos like this, or read your textbook, or pay attention in class, of course. So it's definitely hard work going through all of these videos and problems, but I think that you will definitely be happy in the end. It'll pay off all the hard work when you successfully get through Algebra 1. So keep working hard and you're going to get through it. See you in the next video.